All right, welcome. We're starting our second video on related rates. So this is related rates day 2. If you remember, in the previous video, I mentioned that there's 3 different types of problems for related rates. First one is 3D geometry, and we did that in a previous video. Next one is some type of triangle type of problem. So that's going to be this one. We're talking about some type of triangle problem here, and this one's going to involve motion with cars, and there are some little hiccups that could happen along the way, so I'm going to definitely point those out for you. So here we go. So we have car A is traveling west, 50 miles per hour. So since it's miles per hour, that's a rate. And car B is traveling north at 60 miles per hour. Again, another rate. And both are headed for the intersection of the 2 roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? All right. So when we go ahead and do a problem like this, drawing a picture is super important. So essentially I have car A is traveling west. So I'm going to just draw an arrow here so it helps me with the direction. So this is car A. Okay. And then car B is traveling north to reach some type of intersection. So just put a gigantic dot here. So they're trying to reach this intersection. So we're relating everything to this intersection. Okay, so it's asking at what rate are these cars approaching, and we have these values as well. So we do have the distance for car A. So before we do that, we're going to go with the rates. So dA dt, I have that. And I have dB dt. So again, you need to state your givens. If this is some type of free response, you're going to get points for the givens. So if you can know how to do nothing, but you can get points for givens, that's awesome than getting points for nothing. So dA dt. Now, this is where we're going to have to be a little careful. We're going to have to be using speed versus velocity here. So we're going to be doing velocity because direction does matter. Because if one was going away, the one was going towards, then the 2 cars would actually be getting further away from each other. If they're both going towards or both going away, that matters as well. So since we're going towards an object, we're making the distance smaller. Okay, we're making a distance smaller, then the rate's going to be negative. So again, we're making the distance between 2 objects smaller. It's going to be a negative rate. So since we're going towards the intersection, the distance is getting smaller. This is going to be negative 50. And then this is going to be miles per hour. If you don't mind, I'll just write mph. Okay. So for B, same thing, going north, the distance is getting smaller. It's going to be a negative rate. So this is going to be negative 60 miles per hour. And what are we trying to find? Well, we're trying to find the rate that the 2 cars are approaching. Now, this is where these right triangle problems are almost all the same. If you're not given a hypotenuse, we're going to draw a hypotenuse, and let's just call that C because, well, that's just what we're used to with triangles with A, B's, and C's. So we need to find DC dt when A is 0.3 miles away and B is 0.4 miles away. Okay, so with all these right triangle problems, there's one formula that we all know, and that's Pythagoras' theorem, which is going to be a squared plus b squared equals c squared. Okay? So at this point, if I have any constants, I would plug those in because constants don't have derivatives. So if there's anything that's always constant, I'd plug it in. For example, there are some problems like this where there's a ladder. A ladder would be a constant length, so I would plug in the length of the ladder immediately, and that actually makes the problem a lot easier. Sometimes you have like a boat that's being tethered with a rope. A rope is the same length all the time, so that would be a constant, and you would just plug that in. So I don't have any constants because I have a dA dt, I have a dB dt, and I need to find a dC dt. There's no constants, so there's actually nothing else to do here other than take the derivative. So let's go ahead and do that right now. So taking the derivative of this is going to be 2a, and then we got to tag it, dA dt, plus 2b, dB dt, equals derivative of c squared is going to be 2c dC dt. Okay. Now, you could get rid of all these 2's. It's up to you. I'm not. Just I don't feel like it. And now I actually have almost everything to plug in. I can plug in an A, a dA dt, a B, a dB dt, a C. I have a C. So what can I do? I know. I have to find myself a helper equation. So in a lot of these related rates problems, there are helper equations out there to help us fill in the gaps for some of the stuff. So the helper equation for this one is actually going to be the Pythagorean theorem at this exact point when a is 0.3 and b is 0.4. So when I do that, I'm going to get 0.3 squared plus 0.4 squared is going to equal c squared. Well, luckily, this is a triple, a 3, 4, 5. So c is actually going to equal 0.5. That's super awesome. Now I can plug absolutely everything in. So I'm going to get 2 times a, which is 0.3, dA dt, negative 50, plus 2b, which is 0.4, and dB dt is going to be negative 60, equals 2c, I just found that, 0.5, and I do not know dC dt. So I kept the 2's in here. I kind of cheated a little bit. I knew that this was going to be a fantastic number here, so I didn't worry about getting rid of the 2's, because what is 2 times 0.5? Just 1, so if I should just get dC dt, makes my life a lot easier. Okay, so when I go through here and do all of these, so 2 times 0.3 times 50 is going to be negative 30. So I'm going to get negative 30 plus 2 times 0.4 and 0.8. That's going to give me negative 48. Parentheses to make that a little easier. So the two cars are approaching each other at negative 78 miles per hour, and that's going to be dC dt. And again, it's negative because since the two cars are getting closer and closer together, that's actually going to be indicator. So since we're doing velocity, it's an indicator that these things are getting closer and closer together. So this is velocity. Now, if the question is asking for what's the speed, I just want you to know that the speed is always the absolute value of velocity. So 78 miles per hour. Oop. That would be the speed. Okay? So if this is multiple choice, by the way, they're not going to have these as two different choices. Okay? They're not going to. They'll just either have this one or that one. You would just pick whatever one that they want. If this is free response, they're going to accept both of them as well, because unless they specify the velocity or specify the speed, they'll take either answer. Okay? And that is it for the second day of related rates. It's not too bad, is it? So we did 3D geometry, which was volume, or some type of surface area of cones, spheres, boxes, cylinders. Then we just did a triangle problem, which is always a right triangle problem, and that's going to involve cars. So there's fun ones with police chases. Usually there's like a ladder one involved, in which case would be a constant for one of these. And then up next is going to be actually more right triangle problems, but they're going to involve trig because they're going to talk about an angle, and we're going to use theta. So day 2 is down of related rates.